For 60 years, planetary scientists argued over what sits at the center of Jupiter. One camp insisted the planet was gas all the way down, while the other was certain it had a dense, solid nucleus. These two primary theories were built into textbooks taught on every continent. They served as the framework for our understanding of how giant planets condense and evolve. In the year 2011, NASA launched the Juno spacecraft to resolve the conflict. Its objective was to measure Jupiter's gravity with enough precision to confirm which of the two interior models matched reality. But the resulting data didn't support either camp. Instead of picking a winner, Juno's measurements showed that the two primary frameworks used to explain how massive planets form were both structurally incorrect. This animation shows how Juno actually takes its measurements. It doesn't use cameras to look inside, it listens to how Jupiter pulls it. As the spacecraft swings within 4,200 kilometers of the cloud tops, subtle variations in the planet's mass distribution create microscopic gravitational tugs. Juno detects every single shift via precise Doppler radio signals. The map built by those signals revealed an unexpected structure. A core does exist, but it has no surface. The heavy elements at the center slowly thin out and dissolve into the lighter hydrogen layers, lacking a hard dividing line. The sheer scale of this gradient is massive, spanning roughly 70,000 kilometers outward from the center. You could stack 5.5 Earths side by side across this wide, boundaryless region. Finding a center that acts like a slow dissolve contradicts the physical rules we thought governed how giant planets operate. The standard rulebook for building a gas giant is the core accretion theory. This framework requires a solid, compact nucleus, a clear physical foundation that gravity can use to pull in heavy atmospheric gases. To maintain that theory, scientists proposed a violent workaround. They hypothesized that a massive protoplanet, 10 times the mass of Earth, smashed into a young Jupiter at high velocity, shattering its solid core into a diffuse cloud of debris. But this diagram demonstrates why that hypothesis failed when computationally tested. Over a timeline of billions of years, heavy shattered debris would sink back to the center and reform a sharp boundary, much like sediment settling to the bottom of a disturbed glass of water. Because gravity dictates that heavy materials must eventually settle, an ancient collision cannot account for the stable, diffuse gradient Juno is measuring right now. The final confirmation came from a different source: deep vibrations rippling through the rings of Saturn. Researchers realized these enormous waves were acting like a planetary seismographer. When they combined that ring wave data with gravitational measurements taken by the Cassini spacecraft, the analysis led to a peer-reviewed conclusion in 2021. This cross-section comparison shows that Saturn has the exact same anomaly. Large regions of its deep interior are holding heavy elements toward the center in a diffuse gradient, slowly thinning out without a clean boundary. Finding this identical structure in two distinct gas giants suggests this isn't an accident or an aftermath. It is likely how gas giants form, meaning the models built on solid cores do not accurately describe these worlds. The implications of this extend far beyond our solar system. Astronomers have cataloged, classified, and modeled more than 5,000 confirmed exoplanets. Every assessment of those alien worlds, their cooling timelines, internal pressures, and habitability, was derived from the solid core frameworks that Jupiter and Saturn just broke. The only two gas giants close enough for us to study with extreme precision both failed the standard model test. We have categorized thousands of planets across the galaxy using a structural assumption that likely does not describe what is actually inside any of them. Jupiter still guards deeper mysteries. Its magnetic field is 20,000 times stronger than Earth's, asymmetrical, and features two distinct south poles. Scientists hoped the diffuse core would solve these magnetic anomalies. Instead, the new structure makes the massive ultraviolet auroras burning continuously at the poles even harder to explain. Juno was sent to resolve a specific 60-year argument, but rather than validating a model, it revealed that our standard explanation for gas giant interiors is incomplete, leaving the center of the largest planet in our system as an unsolved problem.